Good morning. This is Professor Jitendra Kumar and I am taking first lecture of material science. In this section we will discuss about phase diagram. So before starting phase diagram, first of all we have to understand what is the basic definition of phase. So phase is the mixture which is physically distinct, chemically homogeneous and mechanically separable. So it can be defined as physically distinct, chemically homogeneous and mechanically separable mixture is called phase. Next term is phase diagram, because we are studying right now this phase diagram. So in phase diagram it can be defined, it is just like a map on temperature composition space showing the stability of various stage. That means it is just like a map on which on one axis composition is placed and another axis temperature is placed. Basically in phase diagram it might be seen that on x-axis composition is placed and y-axis temperature is placed. So this is just like a map on temperature and composition space showing the stability of various states. We will be seeing that different types of states, like there are so many points, important stage which is known as eutectic, eutectide, peritectic, peritectoid. There are so many stages. So phase diagram is simply just like a map on temperature composition space showing the stability of these various stages. Or with the help of phase diagram, melting point of alloy can also be seen. If you suppose that there are so many alloys on phase diagram, so with the help of phase diagram the melting point of alloys can be found. Okay, right. So these components, since we are talking about this phase diagram, so before understanding there are so many components, like there might be one component, there might be two components, there might be three components. Okay, so we will discuss later on how many components might be possible in this phase diagram. Before this before starting these different types of component like unary, binary, ternary, there are so many types of this phase diagram. First of all, you need to understand the degree of freedom. So degree of freedom, it might be concluded that it can be defined as number of independent variables which is required to specify any matter. Degree of freedom is defined as number of independent variable required to specify any matter. In material science, it might be observed that there are three degrees of freedom, like temperature, which is represented on y-axis, composition, which is represented on x-axis, and third is pressure, because pressure is atmospheric pressure, because whatever this phase diagram is drawn, it is basically on our atmospheric pressure. So basically there are three independent variables of phase diagram. Therefore it can be said that the degree of freedom of material science is 3. Okay, because there are three independent variables to specify the material science. So temperature, pressure and composition are 3 degrees of freedom of material science. Okay, next term is Gibbs phase rule. This is very popular formula. It is this formula is equal to C plus 2 is equal to F plus P, where C is called composition, F is degree of freedom and P is phase. Okay, so there might be several compositions. Degree of freedom we have to understand, just to learn before what is degree of freedom. This is the number of independent variable required to specify the matters, and P is phase. Okay, What is phase? Phase is physically distinct, chemically homogeneous and mechanically separable mixture is called phase. Okay, so this is Gibbs phase rule. This is very important. This is equal, this basic formula is C plus 2 is equal to F plus P. Now there are so many types of phase diagram. So depending upon number of components, because there might be one components, there might be two components, there might be three components. Okay, so on the basis of number of components, this phase diagram has been classified into three categories. First one is unary phase diagram. In this condition, C, which is composition, in this condition, this composition C is equal to 1. Next one is binary phase diagram. In that condition, composition will be 2. And third one is ternary phase diagram, in which C will be number of composition will be 3. So this unary phase diagram, in unary phase diagram, the composition will be 1. In binary phase diagram, the composition will be 2, and ternary phase diagram, this composition will be 3. So on the basis of number of components, the phase diagram is classified into three different categories. Okay, so this is the diagram of ternary phase diagram. Okay, this is the triangle, this is equilateral triangular prism. We might be seeing the equilateral triangular prism. So in this equilateral triangular prism, this equilateral triangle is on these sides of this triangle. It might be observed that on the sides of triangle, the percentage of three materials are shown. Like on this side, the percentage of material A is shown. On this side, percentage of material B is shown. On this side, percentage of material C is shown. So it is a three-dimensional plot on equilateral triangular prism, where the percentage of three materials varies along the sides of this triangle, and temperature will be along height of prism, because this is the equilateral triangular prism. So this along the height of prism, temperature is shown. So already we have studied that this is temperature composition space. Temperature composition space. This temperature is shown along the height of the prism. Composition is placed along the side of equilateral triangle, and this is the three-dimensional, therefore it is shown in space, because this is a three-dimensional plot of equilateral triangular prism. Therefore all three sides will represent the percentage of three materials. The height of the prism shows the temperature. Okay, so this is all about the ternary phase diagram. Right, we will discuss in depth about binary phase diagram, because you have to study in depth the binary phase diagram. So in the next session, we will discuss in brief binary phase diagram. Okay, thank you. We will meet in next session.